In this video, we will solve a system of linear equations in a word problem. Here's our example. Taylor and Bruno are out collecting soil samples. During their excursion, Taylor fills up 3 large containers and 2 small containers with a total of 89 samples. Bruno fills up 1 large container and 5 small containers with 86 total samples. Determine how many samples each size container holds. Okay, so before we even begin, before you start writing down equations, you really want to start with defining your variables. So variables are letters that represent something in math. And these somethings are usually what we're solving for. So think about x and y. What are we solving for here? Well, at the very end there, it tells us determine how many samples each size container can hold. How many samples can the large container hold? How many samples can the small container hold? So number of samples that the large container holds, and then likewise for the number of samples that the small container holds. And then in order to define that as a variable, we have to come up with some letter that represents these things. So for the large container, I think I'm just going to use the letter L, and for small container, I'm going to use the letter S, but you actually get to pick those letters because this is you saying, anytime I write L, it means number of samples large container can hold. So you determine what those letters are. Now we want to write a system of 2 linear equations that model this situation, and we want to use everything that they give us. So I'm going to read the information that I think I'm going to need. Taylor fills up 3 large containers and 2 small containers, and there's 89 samples. So if we take 3 large containers, so if we take those 3, multiply it by how many samples each large container can hold, and then 2 times how many samples each small container can hold, we should get 89 total samples, because these are how many samples each of those can hold. And then let's do the same for Bruno. We have 1 large container, so how many samples in a large, and 5 small, how many samples in a small, and we should get a total of 86. So there's our 2 systems. This should look familiar to something that we've been solving. Now it just has some context to it. And now we're going to solve using any method you prefer. Here I want you to pause the video and I want you to solve this system. You can either use addition or you can use substitution. Play the video when you want to see the answer. So I chose to solve this going about it using substitution because I noticed that the second equation had a variable that was almost isolated. That was the L variable. So I just chose to subtract 5s from both sides, and then I had that expression, 86 minus 5s, and then I chose to take that and plug it in for L right there, and that's what you see here. And then I distributed the 3, and then I combined my like terms, and then I isolated the s and solved so that I got 13. And then I had to finish solving for L, so I took that 13 and plugged it back in to my one of my equations. Now this would have been definitely doable using addition as well. So you need to check your solution too, and I'm not going to do that in the video, but you can see that in the solution key provided. And then most importantly in word problems, in context, is interpreting. So it's great that we can do the math, but it's not great if we can't say what the math means. So going back up, I always refer back to my variable definitions. So if S is 13, S is the number of samples small containers can hold. So in a small container, we can put 13 samples, and then in a large container, we can put 21. So that's what we need to write down. That's what our answer means. A large container holds 21 samples, and a small container holds 13 samples. And now we answered the question, we can go back and check, that they asked us, determine how many samples each size container can hold. We answered that, we showed our work, we should check our solution, and we interpreted.